In today's class, we are going to discuss a previous year question from NEET 2025, NEET 2025 question paper, where some basic organic chemistry reaction is given, okay, from reaction mechanisms. So coming to the question, there it is given like a simple cyclopentene derivative, okay, 1-methyl, 1-cyclopentene. First, it is provided with three conditions like hydrobromic acid in the presence of benzyl peroxide is given. Then after that, it is reacted with potassium cyanide and followed by a simple reducing agent, sodium and mercury amalgam in the presence of ethanol. So let me give you a simple basic idea regarding this question where we are going to discuss, okay, regarding the Markovnikov's rule. Markovnikov's rule and anti-Markovnikov's rule. Anti-Markovnikov's rule. In Markovnikov's rule, see the statement would be something like this. In electrophilic addition reactions, the nucleophilic part of the reagent, will be added to the carbon with less number of hydrogens. R will be added to more substituted carbon. Atom. Like see here in this case, let me give a simple example for this statement as it is given. See, for the same reaction that is given in the question, that is 1-methyl cyclopentene, whenever it is reacted with HBr in the presence of sodium bromide or FeBr3, something like this, where you will get from this hydrobromic acid, you will get H plus and Br minus. Okay, so as I said in the statement, in electrophilic addition reactions, so electrophilic addition reactions, the name itself indicates first the electrophilic part of the reagent, that is H plus, will be added to the center, that is olefinic carbons, okay, olefinic center of the molecule. So when you go for this statement, you can add, you have got two possibilities, like you can add this H plus either at the more substituted carbon, like let me specify it as RF. Let me go for, okay. So whenever H plus is approaching, consider it is attacking from this side, so you will get H plus being added at the methyl side. H plus is here and methyl is here, and you will get a positive charge over here. And there is one more possibility, if H plus is being attacking from this side, you will get hydrogen is being placed here, methyl is over here, and you will get a positive charge over this side. Okay. So here in this case, the carbocation formed is a secondary carbocation, and in the other case, it is a tertiary carbocation. Okay, and you can go for their relative stabilities of carbocation, as tertiary is more stable than secondary than primary. So the more possible and feasible mechanism for this reaction is the second one, that is H plus is being attacking the less substituted carbon. And by default, the nucleophilic part of the reagent, that is Br minus bromide ion, by default attacks the more substituted carbon or more stable carbocation center. Okay, and you will get the major product as 1-bromo 1-methyl cyclopentane, 1-bromo 1-methyl cyclopentane. Okay, and this is according to Markovnikov's rule, and it is formed as a major, and by default of even you will get the other product from the other mechanism, that is 1-bromo 2-methyl cyclopentane as minor product. So you will get this product according to Markovnikov's product, but you can go for anti-Markovnikov's rule. and when this will be applied. So this is simple, quite opposite for Markovnikov's rule. So the attacking reagents will be changing their positions, relative positions. So see the same example again. You can go for 1-methyl cyclopentene whenever this is reacted with the HBr. Now, to get into this anti-Markovnikov's rule, to follow this rule, you need radical initiators, so-called radical initiators. Okay, and what are the radical initiators we have got in this case? See, usual radical initiators will be peroxy acids like MCPBA, metafluoroperbenzoic acid. Okay, you will be given more popularly this one. So you can make an arrangement for this. So in this case, you will get HBr, and this HBr won't be converting into H plus and Br minus. Instead, it will be converted into hydrogen radical and bromine radical. Okay. So the simple quite opposite products will be expected in this case. Now in the previous case, we have attacked this bromine over this center, but now in this case, it will be here, and this will be formed as a major. 1-methyl cyclopentene on reaction with the HBr in the presence of benzoyl peroxide. Benzoyl structure is something like this. Benzene C double bond O H. Okay, you will get H bromine radical and hydrogen radical, and by default this bromine radical attacks the less substituted side of the olefinic center, and which is on further reaction with potassium cyanide, it is simple displacement. So you will get cyclopentene with cyanide on one center and methyl over here, and this cyanide center on reaction with sodium mercury amalgam in the presence of ethyl alcohol. This is simple reduction. Okay, and reduction of cyanide in the presence of dry medium, you will get amine CH2 and NH2. So the answer would be the option A.